Hello friends, welcome back to another video tutorial. In this video tutorial we are going to learn about what is software debugging. So as defined by the Google, software debugging means to identify and remove the errors from our code. So by writing code for some program we might come across many errors. So in order to remove those errors and identify them, that is called software debugging. And coming to the types of debugging, we have many types of debugging. Of them, few things are print debugging, which means that we put some printf statements or cout statements and then try to print out the variable values and debug. Remote debugging, it is done by the professionals who have the remote access to servers. Also, post-mortem debugging. In post-mortem debugging, what we do is we'll have the dump file after the crash has occurred and then we try to backtrace. Visual debugging. In visual debugging, this is generally done in modern days IDEs like Visual Studio and then Eclipse and so. And we also have some console-based debugging, which means we use command prompt, we put the breakpoints and then we do the debugging in the console. Coming to the types of debuggers, we have a few types of debuggers. We have firstly GDB. GDB stands for the GNU debugger, which is generally a console-based debugging tool. Secondly, we have the Microsoft Visual Studio Debugger, which we are going to learn in today's tutorial. And then we have the Eclipse Debugger API. This is generally used to debug our code in Eclipse. This is used for Java and Node.js functionalities. And Emacs is a text editor which is cross-platformed, and then we can install some debugger plugins and then we can debug. This is about the intro about the software debugging. So now let us start with the things which we do now. So let me open the project. I have just created a project in the Visual Studio, and then this is an empty project, so we need to add a source file. Click on add new item. Let me name it as main.c, and then we start writing the code. Let me include our standard library, and then let me start our main. The template for the main, and then let me put a statement. This statement is used for Visual Studio to tell the command line not to exit out after its execution, or else it will get out of the execution mode. And then next, today now I'll write the program for calculating the reverse of a given number. So to calculate the reverse of a given number, let me write a function. Let me take the return type as int. Let me name the function as reverse num, and then let me pass a number as a parameter. So now let me create a variable answer which is initialized to 0, and then I need to return the answer. And now all the code which we want to do will sit in between these two lines. So what we'll do is we'll put a while loop generally, and then we'll see if the answer is greater than or equal to 0. What we do is we'll multiply the given previous answer by 10 and add the current remainder, and then we break the given number by 10, and then this is how we calculate the reverse of a number. So, and then now let me use the above function below. So I will declare a variable number, and then I'll ask the user to enter the number, enter any number. I'll ask the user to enter a number. He'll enter a number. To take the input, I'm using the scanf. But then in Visual Studio, scanf is not recommended. They use scanf_s. This is more safer than the scanf. And then the return the type of the variable being int and taking %d, and then I need to store it in the number, so I need to give the address of the number. Now I took the number input. Next thing is, now I need to print out the reverse of the number. So I'll print out saying that reverse of so and so number is so and so. So the first parameter being the number and the second parameter being the reverse number. So reverse number, I'll pass the parameter as number. This function will calculate the reverse of the number and return it to me. And then we are going to print it out here. The first one is the number and the second one will be the reverse of the number. So this is a simple program. Now the code is completed. Now let us try running the code. Let me take out the unnecessary spaces. Done. So now we'll start executing the program. Wait for it to build and then to get executed. So it is asking for us to enter any number. So let me enter some number. I am entering 1, 2, 3, 4, 5 and then hit enter. And if you see, it has given us some garbage value which says some 1.5 negative 1.5 billion also, but then what we expected is 54321, so which is not the correct answer. So here is a bug. So what we need to do is we need to close the application, and then now here comes the thing of debugging. What we could do is, what the first thing which we need to do is we'll put a breakpoint. In order to put a breakpoint, we need to go in the left side bar and then place a red dot over here. This red dot is called breakpoint. So what happens is that generally if no breakpoints are present, the execution starts over here and then it goes line by line. But then if you place a breakpoint over here, whenever your execution hits this line, it stops over here and it waits for you. So now let's start. So after keeping the breakpoint, let us start the execution and see. So we have put the breakpoint over here, and then now we need to start the debugging. So in order to start the debugging, we'll use three main functionalities, which are step into, step over and step out. I'll tell you about each of these now. These three buttons are present over here in the menu bar. If you are unable to see them over here, you can go into debug menu. In that you will be able to see these three: step into, step over and step out. So what this step into does is that it executes the current line and goes into the next line. So if you press this step into, it executes the current line and then it goes into the next line. So it has actually gone into the stdio. The reason is that printf's definition will be in the stdio. So it has gone into the stdio and then it is now ready to print the statement which we want it to be printed. Now I have pressed continue. Why? Because I don't want to see the whole implementation of the printf. What next I could do is I'll enter a number 1, 2, 3 and then I'll hit enter. Sorry, we have not placed any breakpoint after this execution. Let me stop the debugging and place a breakpoint at this printf statement. So let me run the code again. Let me remove this breakpoint and then restart the program once again. So it has asked for us to give any number as input. I am giving 1, 2, 3, 4 as input. So now we are at this current statement. So what at this current statement, and then now the step into. If I press the step into, what would happen is that it will go and it will execute the printf functionality. But then what I am interested in is I want to test the functionality of this function. In order to test this functionality, we are sure that after the execution, in between of this execution, we'll come to the function call. So what I do is I'll put a breakpoint over here in the starting of the function, first line of the function, and then I'll hit continue. What happens then is this the next printing function will be called, and then in the print function this reverse number function will be called. So the reverse number will come over here, and then we'll hit the breakpoint. Let us see that. So I have hit continue, and then we are currently at this line of code. So now step into. So when you press the step into, you go line by line. I mean, see, we are currently in the line fifth line. If I press step into, we'll go into the sixth line, and this yellow marker arrow shows the current line of execution. If you hover over your mouse over there, it will tell you that this is the next statement to be executed. So if I press step into, it will step into the function, I mean the next line of code. It goes on like this. This at the current time, what you could do is you could actually now comes the main part about the windows, locals, autos and watch. Autos windows, what this autos windows tells is that it will show all the variables which are present up until the current line. So until the current line, what are all the variables? We have one number variable, and then we have an answer variable. These are the variables which are above our current line of execution. So this window, autos window, it shows those variables. Locals window shows all the local variables which are present in the current scope. In our current scope, we have only two variables. One is the name and the second one is the answer. So the locals window shows all the variables which are in this current scope. And then coming to the watch window, if you want to, let's say I want to watch the value of the answer while this code is getting executed. So what I could do is I can put the value answer over here and add it to the watch list. This watch list can be observed like while doing the execution, the change of the value can be seen over here. See, the value changed from 432, it was previously 43. So the usage of the watch is in this way. And then next one, coming to the call stack, and the call stack is useful to trace the order in which functions are called. So as we all know that generally any C program starts from the main, and then program execution starts from some external code, some OS code will be calling our main function, and then at line 20, which is at over here, we have a function called to the reverse number. So the function call, what it does is it jumps the execution control to here. So we go into line 4, and now currently we are at line 5. So that status will be given to keep track over here. See, we are coming from some external OS code into main function, and at line 20 we have broken, and then now currently we are in the line 5 of reverse number. Call stack is used in that way to trace back the functions. Next, coming to the breakpoints window. Breakpoints window will show you all the active breakpoints in the current code. In the current code, we have only two breakpoints. One is at line 20 and in the function main, that is shown over here, line 20 in the main.c file, and the second breakpoint is at line 5 in the main.c file. These breakpoints can be disabled by unchecking the checkboxes over here. So now and then autos and locals and watch. And then watch is of two types. One is quick watch, when you hover your mouse over to the variable, and then you are able to see the immediate value of the answer, which is some 1.4 million. This is called quick watch. And if you pin it over here using the pin button, it will be pinned over there, and then you can actually see the value throughout the execution. If you step into also, you could see the changes in the value of the answer over there. See, it is currently 0, and now it has become 3 and then 2. That is how the pinned watch. This is called the pin watch. You can close it out and exit it out. So now we need to debug our code. So what I do is, firstly we have put a breakpoint over here, and then we'll start the execution. Let me enter the number 123. We'll go into this function. So firstly the logic is that we need to get the lastmost number of the thing. So the answer should become, so you can keep track of that answer, and then you can also keep track of the number in the watch list. This watch list is useful to keep track of the variables. That is the main reason. So we'll print we'll step into the execution, and then the answer is 3 as expected, and then the answer is 2 as expected. So the number is getting reversed, 3 2, and then next what we expect is we expect 1. But then after the number is becoming after the answer is the code for this is that now we found out the bug. The bug is that here we shouldn't write the answer, we need to write the number. So what we do is, one thing is we can stop the debugging, and then we can write the number over here, and then we can rerun the code. If we rerun the code again, we need to see the same thing. We'll continue, and then we'll step into this. We'll see if the required results are coming or not. As you can always look over here for the changes. So now the answer has been the reverse of the given number. Now see, even though we have come to the end of the thing, we are not getting outside it, and the answer is getting incremented and it is getting overflowed. This is the reason why we got some garbage value of negative previously. So what we need to do is we need to terminate the while loop when the number becomes 0. That is a bug. So what we do is we'll stop the execution, and then we could change the code to only if the number is greater than 0 we need to execute these two corresponding lines of code. Yes, let me enter any number 1 2 3, and then again we hit the breakpoints. So in order to, right now I don't want to use this breakpoint again, so you can directly click it on again, and then the red dot will be disappeared, and then you can click continue. So you can click continue again, and then if you see we have read the correct thing. I mean, we have entered 1 2 3 and the output is 3 2 1. So we have finally removed 2 bugs from our code. And then now I'll tell you about the other 2 functionalities, step out and step over. Let us say we put a breakpoint at over here. So we are currently in the line of execution printf. Now I don't want to see the execution of the printf, I want to come into this line. So what we could do is we want to step over the execution of this function and come to the next line. This is called step over. So in the step over, what it happens is it executes of this function and then goes into the next line. So if I press step over, it will print out that line for me in the console window, and then it will come into the next line, which is indicated by this yellow arrow as said before. So now this is the functionality of step over. What step over does is it executes the current line, and the function which is used, it doesn't go into the printf's definition which we have previously seen in the stdio.h. It will execute it off, and then it will wait in the next line. That is a step over. And then step out, I'll demonstrate the step out function in the next function, like when we go into see. So we are now in the scanfs function, but then let us say that I'm in some line 13 15. Now I don't want to execute the code which is below this line. So what I could do is I could do step out. What step out does is that it goes back to the previous function. And now how it keep track of that is that it goes into the call stack and then it goes into the previous function. So it checks for the previous function and then goes over till there. So we were previously at line 19, which is shown over here. So what we do is when I press step out, so it has stepped out, and then we are currently in this line of execution. How to know that? We could put a breakpoint over here, and then if I press any number 1 2 3, see, we have come out of that scanf's definition. It has run in the background, and then we are currently over in this function. I will again show you one more example of step out for you to be clear. So now currently we are in this function, I mean reverse number function. Now I let me say that, let me step into 2-3 times of execution of loop. Now I have said that I have found that these lines of code are correct, and then I don't want to execute these lines of code, and then I might have found that I have a bug in another function, so I don't want to debug. So what we could do is, we are currently at this position, right? So when I press the step out, it goes into the stack frame, and then it goes into the previous function which called this. So when I press the step out, it goes into the previous line. So this function has called it. How did it get to know? It uses call stack, and then it went to the previous line of execution. Now this line will be executed if I press the step into, but then if I press the step into, it will go into the printf definition, which I don't want. So I wanted it to be executed in the background, but then I want to see the output in the console. So that what I could do is step over. What step over does, it executes the current line of code, and then it goes into the next line, and then it waits for us. So it has reversed the given number 1 2 3, and then it has printed out the result for us, that is the reverse. And we can continue at any point to exit out of the code. So we have finally exited out of this code. This is how we do visual debugging with Visual Studio. I hope I have explained about everything. Step into, it steps into line by line. Step over, it steps over it executes the function call in the present line, and then it waits in the next line. What step out does is that it stops the execution of a function in the current and goes back into the previous. A quick watch is done when you hover your mouse over the variable, as I have shown for the answer. Pinned watch. On the quick watch, if you pin it to the Visual Studio editor, it will get pinned. Locals are the variables which are present in the current scope. Autos is local variables, but then which are present above and on the current line. Locals are the all local variables, but then autos are only a few of the local variables which are available above the current line. Coming to the watch is a window which is used to add the custom variable, and then we can keep track of the changes to the edge to the watch, and then at the runtime. Call stack is used to know in which order the execution function took place, and then in which order we came till here. Breakpoints are the things which can be put in the code, and then which we will, on hitting of those, the execution of the program stops. That is it for this video. Thanks for watching this video. Share this video and like this video if you liked it.